Ladies and gentlemen, welcome to Logical, Plausible, Probable. I'm your host, John Maddox, and tonight we're having another stream you just won't want to miss. If you've got what it takes, click that link or prepare yourself, for this arena is not for the weak. Now, let the mental combat begin, but always make sure your arguments are LPP.
What is going on, everybody? Welcome here to a late night Logical, Plausible, Probable. I'm going to be reviewing a awesome debate between Perry Marshall and PZ Myers on, basically the plausibility of evolution and, is there any questions to be had about neo-Darwinian theories and our, different aspects of the weaknesses. Basically, are they being actually addressed or are they just kind of being ignored? And for those of you who are wondering why I might be doing this review, it's probably because earlier today I had the opportunity to have a live conversation interview with Perry Marshall himself. We talked about his book, Evolution 2.0, Bridging the Gap Between Darwin and Design, which was awesome. And folks, you should be excited because apparently he enjoyed it enough that in March, I'm going to have him on again for another interview. We're going to go into conversation about his paper that he published very recently. I think it was back in March 2021, and where he challenges the chemicals to code to cognition model that kind of governs so much of modern biology and philosophy, for that matter. And does a deep dive into why it should be basically the direct reciprocal. It should be cognition, codes, then chemicals being necessary for all those things to happen because of computation, choice, information processing, all these different things that have to go into effect in order for the things that we take for granted in biological systems to actually be viable products. But before we get into the review, want to give a big shout out, and thanks. What's up, Andrew? Awesome member. Also give me a super chat. Thanks so much, man. This is epic interview, LPP. Looking forward to the next one. Appreciate that very much, Andrew. I think Utopia Busters in the house. We got Greeny, some awesome members. Thanks so much, guys, for your support and helping make these things happen very, very much. Kajaro's in the house. What's up, man? Redefine Living. How are you? Sea Science is here, and we should be getting into a good review here real quickly. And folks, if we want to do a little bit of a after review open mic, let me know in the side chat, and I will think about open up the stream for that as we get close to the end. Okay, without further ado, folks, let's get into this. It was a very interesting conversation. Originally, it was over on the Unbelievable show over in the UK. And I think it was back in 2016. It's kind of interesting because some of the things that I'll mention, if you pay close attention, some of the things that PZ Myers uses actually throughout this debate back in 2016 to kind of basically claim that Perry didn't know what he was talking about, kind of turns out there's been a bunch of papers since then that actually support the positions that Perry was taking in this debate. But just keep your eyes or your ears peeled for things that are going to be happening. But without further ado, let's kind of jump into this a little bit past the introductions and get into the meat of this.
Substantial amount of headway starting with that, and I found a tremendous body of literature connecting genomics to communication theory, and there's journals on bioinformatics, and so then things begin to make sense. Now, to fast forward the story quite a bit more so we can get into this discussion, I realized that error correction and error detection were absolutely critical to any kind of communication process and any kind of DNA replication. Yet the Darwinian view was that random copying errors, among other things like population genetics and gene flow and things like that, were major drivers of evolution, and that it was inevitable that copying errors and things like that would inevitably produce new structures, new organs, new features, and natural selection would select them, and that you would have a constant improvement just naturally with time. But everything I knew about software said software doesn't work that way. And having written an Ethernet book, copying errors never, for all practical purposes, they never help. So I had a giant discovery moment when, well, let me just say that for a while, so I'm looking at evolution and I'm going, I find lots and lots of anecdotal evidence that there is evolution. I don't think the creationists are right on this. I don't think this is all fake. However, the mechanisms that they're telling me about don't make sense from mathematically and engineering ways. And then I discovered the work of Barbara McClintock. And her story is she kind of approached problems like a hacker, and she was hacking corn plants in 1944 using very measured doses of radiation. And she damaged a chromosome of a plant, and the plant threw her a curveball. It did something she totally did not expect. And if I might use an analogy, what she had done was she had ripped a page out of a novel, and the plant. So if you can imagine ripping a page out of a novel, giving it to one of your friends who's a writer and saying, I want you to fill in the missing page by reading what's before it and after it, and use words and sentences that are already in the novel and make it all make sense. And this is essentially what the plant did. And she called this transposition. The genes, certain genes were moving around and changing the expression. And
it kind of rewrote itself. It sort of repaired itself.
Yes. The cell repaired it. It rewrote its own code. And she presented this at a symposium, and half the people there laughed at her and the other half were angry. And they were like, who does this woman think she is, suggesting that plants can re-engineer their own genetics? And they didn't accept it. Well, in 1983, she won the Nobel Prize for discovering transposition. And I believe that what she really had done was she was one of the very first scientists to observe evolution actually happening in real time and understand genetically what happened.
I mean, obviously, this is just scratching the surface, which you delve a lot deeper into in the book. But essentially, what I take away from this is that you've developed this view, which you say is simply kind of bringing to the surface a lot of the science that's already out there, but essentially not talked about much in the public sphere. That essentially there's a sort of, for want of a better word, intelligence in the cell. There's a purposiveness almost in what the cell does. It's not just a case of, as you say, random mutation.
Now, before we continue on with that point there, something that I think folks kind of forget about in terms of the reuse of different portions of the genome is, what's necessary for that to actually occur. Are we talking about a orderly extraction of, function A and then an application of function A over in situation A that hey, it may not be being utilized in this capacity in the current form. However, there's a potential utilization of it over here for a new variable. And anybody who has done a modicum of analysis of what we're trying to pull off in a lot of our artificial intelligence systems right now is we're trying to create those kinds of programs currently. Like, hey, how can I have a system that has the flexibility to not be 100% limited to this particular application? And if there's a new scenario, maybe function 1 and function 2 aren't written specifically to account for this problem. However, there's enough flexibility in them that, hey, maybe we can apply function A and B to problem 1 and together they can solve it. Or maybe with machine learning, we can figure out a way to be able to account for it, even though it hasn't actually been a predetermined variable to account for, right? And then, like, this is what we're trying to do in our systems as we speak. And the fact that what we're learning about transposition and other aspects of what the biological systems are pulling off, it's like the most bad to the bone artificial intelligence system that's operating here, but is being able to anticipate and or deal in real time with unforeseen variables, or just not as unforeseen, but like, oh, well, yesterday it wasn't having to account for this, but today it is. So let's go activate X, Y, and Z in order to take care of this. I mean, it's totally amazing stuff, folks. And the fact that it just gets glossed over as like, oh, it's just random mutations and natural selection and, chemical reactions, blah, there's nothing else going on here from an information processing standpoint. It just showcases the astonishing desperation for the Evo atheists to avoid the obvious. But let's continue.
Naturally selected over a long period of time, there's kind of a sense in which the cell is doing a lot more than we ever gave it credit for.
Yes,
in that sense.
They are most emphatically non-random. They're anti-random, in fact, I would say. And so now evolution began to really make sense. And Barbara McClintock was only the tip of the iceberg. And then there was the work of Lynn Margulis on symbiogenesis. There was Ono's to our hypothesis. There was epigenetics and horizontal gene transfer. And when taken together, these mechanisms actually explain what's going on, and you can observe them in real time. And I thought this is so much more interesting than what the intelligent design guys are talking about. And this is so much more interesting than the traditional Darwinists are talking about. Why isn't anybody talking?
Okay, interesting. Well, we needed to take a little time to explain where the book came from and the central thesis behind it. So we can begin this conversation now with PZ, who's on the line and is going to be taking part in today's program. PZ, you've run into Perry's work before. You've not been very complimentary about it. So what's your take on?
Okay, so before we get into the PZ Meyer stuff, this honestly cracks me up listening to him as we get going. Like, you can tell this guy is so butthurt about anybody daring to challenge the conventional paradigms of neo-Darwinism. It's actually kind of funny. And what cracks me up more than anything is, and I'm going to bring this up again later when we get to this point, but you can tell that PZ Myers is one of those biologists that Perry and I were talking about today, who are just like oblivious to information communication theory, are part of the old school, who is trying to just desperately cling on to the, like, let's ignore all these things we've discovered and like the just deluge of evidence in favor of information processing, coding, like AI equivalents. I mean, it's truly astonishing how somebody, the old guard of academia are just desperate to avoid what is an unavoidable reality and what so much research is being focused on. Like, oh, okay, we have to account for X, Y, and Z in cancer research and such. But people like a PZ Myers just want to be like, you question my conventional paradigm. You must be an ignorant fool who can't understand anything about biology. And it's like, dude, this is like, I'm not saying there's not amazing stuff that's going on. It's very complicated. And there's like incredible specificity and dedication and detail that has to be accounted to like understand these systems because they're so freaking amazing. But that doesn't mean you can just be like, those principles don't apply when they clearly apply. And it's not just folks like a Perry Marshall or myself or Stephen Meyer, all these different folks who are like questioning the conventional paradigm. It's not like we're just out to lunch on this stuff. Like, this is well-established things. But anyway, let's continue.
Perry, do you think he's just recycling sort of intelligent design perspectives? What's your take on what he's trying to do?
Well, he's trying to put a new twist on it, but he's getting it all wrong. That for instance, when he's, what I thought was very telling, it's also telling in the book, is he's a software person, he's an electrical engineer, and he's trying to impose his perspective on biology. So he says, okay, that biology doesn't make any sense when I look at it as the way software works. And instead of saying, well, maybe my analogy is totally off base and wrong, he says, what we've got here is a situation where the biology doesn't conform to his expectations of how it will work. And yeah, biology is far more fault tolerant than electrical engineering. You can't directly compare it to software or code or anything like that because it's got a lot more complications going on with it. Then on top of that, in his book, what he tends to do is throw out science buzzwords like transposition. And the transposition discussion is a good example of this. He throws them out, but he doesn't really understand them. He's got McClintock totally wrong. McClintock's work, which was marvelous work, and yeah, it was not initially accepted because it was difficult stuff. If you read her papers, she's got an amazing mind. It's really complicated, really difficult things to understand, and that's largely why it wasn't immediately accepted. But she was very convincing because she brought the data to bear. But all of her work was on something called genetic instability. Okay, it's not about cells engineering solutions. For instance, the stuff on bridge breakage fusion that Perry mentions, that's about random chance breakage of chromosomes that have exposed ends. They tend to refuse, and then when mitosis or meiosis occurs, they break, and they break in random places, not in designed, engineered, planned places, but in an entirely random way, which means that the progeny of that cell will exhibit greater genetic variation than the parent. There was absolutely nothing in McClintock.
One of the things I always find interesting about the people like PZ Myers and their desperation to hold on to everything just being random is, we have things like splicing signals in introns, right? So we can have alternative splicing of a gene sequence, which results in a whole plethora of different variable possibilities for a gene and the way it's read and what the end outcome is. But you have to have the splicing signals, otherwise the spliceosomes won't know where to go and where to organize things, right? Same thing with transposons, all these different things you have in transposable elements. We know that there's very specific locations that they get excised from and then reinserted into, and then they execute a specific function based on location. But then you got people like PZ Myers like, no, this is just completely random breakage, and where they reattach together, there's no preceding reason for it, even though they're able to identify the likelihoods of where these things are going to happen based on different signals. Okay, dude, that's like saying in a construction site, you've got different sticky notes on the instructions for the day for the team that's coming in to do whatever, and there's some extra notes here oh, do this, or in a an architect's blueprint there's specific notations of where you're going to do X, Y, and Z, has this special part here, so on and so forth, and then being that's totally random, guys, totally random, just saying. Yeah, nobody would make that argument in any other context, but hey, evolutionary biologists love to.
That's work that argues against the importance of chance in this business.
Well, can we maybe start to open up that area before we progress on to any more? Just from the point of view of, okay, you're saying, PZ, at base, you think the analogy is all wrong. Perry's come to this as an engineer. Well, this isn't computer engineering we're talking about. This is biology, very different thing, different types of tolerances, different kind of thing going on. And then you've obviously got some specific criticisms about the way he's interpreted that particular work that he spoke about. Okay, the obvious question that the PZ has aired here, Perry, is, as I asked, why is an engineer, no matter how good he may be at engineering, writing a book on evolution? You aren't a qualified scientist in that sense, and a lot of people will probably throw your claims out the window just on that basis alone. Why do you believe an engineer does have the right to throw his hat into this ring?
Well, we build models in science, and all scientific descriptions are models. All scientific descriptions are analogies. If I drop a steel ingot off the building onto the ground, I can use calculus to calculate its trajectory, but the calculus is not a steel ingot, and it's going to have a margin of error. The question at hand is, do the models of information theory apply in biology to the rearrangement of code? And we have huge bodies of literature going back to the 60s that say, yes, it does.
The DNA is an information code. It's not simply like an information code. It is an information
code. And I would certainly acknowledge that it is more than just a computer program, but it is not less than a computer program. And the rules of information entropy and all of that.
Now, the point that Perry just made right there on the fact that it is more than a computer program, but not less than. that is a point that I have made over and over and over again in the, to address so many of the standard dismissals and hand waving by folks in debates and just, open discussions, comments and such, that, oh, well, our computer programs don't do X, or our computer programs can't account for Y. Therefore, what's happening in biological systems is not code. It's not equivalent to. And it's like, ugh. And one of the things I'm actually going to bring up with Perry, because he addresses this in his paper, and we didn't really dive into it too much in today's conversation, but the whole aspect of being Turing complete, right? So anybody doesn't believe me, like, go Google what is Turing complete, and then you can look up places. There's papers I've got in my folder on how the genetic code is Turing complete or Turing equivalent, depending on which term you want to use. You have Turing machines and ribosomes, and the overall cell processing is a Turing machine, so on and so forth. And what's interesting is, and this equates to the point that Perry's making here, is about it being more than, is our cells can do everything that we would equate with a Turing machine in terms of capabilities perspective, but also do more than, can actually create choice, have choice in what is being executed, not just be limited to predetermined functions. Like in most scenarios, hey, just operate like a normal computation mechanism, do X, Y, and Z. However, if new variable, then interesting, let's create choice, insert choice into the equation in order to come up with a appropriate solution to a problem. And that is one of the key distinctions that people just want to gloss over, and really not consider in terms of what are we actually analyzing here? Like, is it just nothing but completely random modifications, or is there controlled cognitive function being executed, and not necessarily from the conscious perspective that we think about in terms of what we're doing, but is there cognition actually taking place on the cellular level in order to execute these functions, whether it be on a day-to-day perspective, accounting for real-time variables, or even when you're getting into like restructuring of pre-existing functions to create a new solution to a previously unforeseen variable. It's really fascinating stuff, and I think it's something that gets glossed over very often in these conversations.
Work. Now, PZ said that biological systems are much more fault tolerant. The reason they're more fault tolerant is because they have layers and layers of error detection and error correction. So when radiation damaged the chromosomes, the plant repaired the chromosomes non-randomly. So yes, the damage was random, but the repair was not.
PZ, why do you think he's got this research so wrong exactly? Can you explain?
I have no idea. That's very bizarre, because what's going on in McClintock's models are that chromosome ends are broken, and they tend to fuse back together. Cells hate single-stranded DNA just hanging out there. So what they'll do is they reanneal with the two broken ends will stick together. And then when the cell divides and they have to separate, they will break in some random position on the chromosome. The only repair mechanism here is that it doesn't tolerate dangling ends. Okay, it fuses dangling ends together. But the actual repair is, in essence, randomly damaging to the ends of those chromosomes. McClintock also studied transposons, transposition, which is basically where there's an enzyme that copies out a piece of DNA and then inserts it into some random other spot in the genome. So it's a well-understood phenomenon. It's actually used in a lot of biotechnology techniques. And that, again, is also a random process. That often what happens when you have a transposition is that it inserts that copied sequence into a place that's damaging to the cell, or
one of the things that always cracks me up about these kinds of talking points is if you take the time to just go Google it and be like, I wonder if we've discovered that insert Evo atheist talking point has actually been contradicted, or there's evidence in the contrary. And it's like, let's go Google it, see if it's non-random. And then there it is, like, non-random. It's like, when was that? Oh, papers coming out of nowhere that actually it turns out that we're seeing evidence that it's not random, and there actually is reasons and signals for these things that we used to think were completely bizarre and there was no reason for them. And it turns out the reason that we thought there was no reason is we hadn't yet done enough research to determine whether or not there were reasons for it. It's amazing how that trend continues.
shifts regulation, or in many cases will be in a totally neutral place and does nothing at all.
So there's two problems with what PZ said. One is that that error correction in this case is just repairing broken ends. And the latest Nobel Prize discusses 3 layers of error correction, which result in a copying error rate of less than 1 in a billion base pairs. And the correction of the errors is explicitly non-random. Transposition is also non-random because if you get a book on transposition, it shows that transposable elements tend to land in specific places and specific patterns. And if you read McClintock's work on this, what's going on is explicitly non-random. Now, Peasy's claim that it's random is not mathematically provable. Okay. And what I found was that in every instance, when I started chasing things down, I would find a pattern rather than evidence of randomness.
I mean, what Perry sees as patterns, do you just see as, I don't know, what do you see it as, PZ, if it's not a pattern and some kind of a purposiveness within the cell?
Well, of course it's a pattern, but it's a random pattern. Patterns can be random. So when McClintock describes the patterns of variegation in corn, for instance, that are induced by these breakage models of the chromosome, what she was actually seeing is variation in the structure and the color of the tissues that was random, that was driven by random processes. It's hard to argue that there was a scheme or a plan behind them, because we understand the mechanisms for how this was generated. And we can see exactly how it happens. And it doesn't seem to involve any kind of design elements. There's no engineer inside the corn plant deciding where things go.
Okay. You believe that there is some kind of an engineering principle going on. I don't know if you would hazard a guess at how that happens, but as far as you can see, Perry, you observe it happening in all that you can tell.
I predict that there is a mathematical model or matrix that is dictating what is going on, and that is a testable hypothesis. Peasy's assertion that it's random is not a testable hypothesis because it's not even possible to prove that it is random. So Peasy, my question for you is, how do you know that it's random, and where is your proof?
All right, so before PZ responds to the challenge, just so you know, folks, there's papers from 2020, 2021, all about how there is non-random translocation. I mean, it's so funny. It's like, it seems that the rearrangement has reasons for it. And, you know, it's in standard Evo atheist form. Myers wants to be like, well, there's no engineer like in the cell doing all of this. Like, where's the conscious agent? And if there's no conscious agent, then the points you're making don't exist and aren't plausible. And it's like, dude, next thing you're going to try and tell me that if you observe a AI system that humans create do something that isn't necessarily 100% pre-programmed, that you're going to need to have a conscious agent inside of the, a ghost in the machine that's doing the the computation in order to come. It's like, dude, I know you're getting old and you're angry, and the fact that your worldview is starting to implode and your professional, all the things you've been doing and the arguments you've been making professionally for decades are starting to crumble around you. But dude, if you don't understand how like any of this stuff works in terms of AI and even the baseline of what we're trying to do with machine learning and such, you really, and you're just gonna dismiss all of it. It's chemicals, therefore it's just a bunch of random stuff, therefore all the points that are being made and all the principles that are being applied, they don't actually exist in relation to this conversation. I'm just gonna put my hands over my ears and be like, you don't know what you're talking about. Like, dude, it's getting embarrassing. It's really getting embarrassing listening to the Evo atheists go down these rabbit holes, and then just it's so obvious how they don't know what the hell they're talking about in relation to information communication theory and computation. It's really getting embarrassing.
So in biology, randomness is an operational property. What you do is you do the experiment, make predictions about the results you will get. And what you typically see in these kinds of experiments is that you can't predict where the mutation will occur. For instance, if you're inducing mutations, you can just predict that it will occur with some frequency. And you do many repetitions of the experiment, and you can get a nice distribution of where mutations occur in each event. You can plot these out, and you can see that they're actually fairly random in what they do. That's all we care about, is that there's a process we can use to determine whether a particular event was predetermined by other prior consequences or whether it seems to be arbitrary.
Okay, all we care about is if it was predetermined causes, etc., etc. Oh my goodness, PZ, dude, do you actually think about what you're saying here? That is so obvious that you are desperate to avoid any implications of teleology in this conversation. You're so desperate for it that you're going to be like, no, I'm going to cling to the preconceived notion that this is 100% random and that it is not even remotely plausible or probable that there is a matrix that is controlling this. Like, it is obvious that this is what's going on. So obvious. And quick sidebar, folks. Andrew Cumming is asking a question, which I've addressed many times. He says, why do you keep using that term Evo atheist? That's not a given description necessarily. Okay, well, I apply it directly to individuals such as P.Z. Meyer, who is a well-known hardcore atheist and an evolutionary biologist. And usually since I am the one I believe that came up, I coined the term Evo atheist. So I get to use it however I want. It's a term that I came up with. Okay. So let's take that as a first point. Second point would be, if you're an atheist who actively utilizes evolutionary theory as a mechanism to completely defeat, from your perspective, the viability of theism, then hybridizing your positions to be much more specific in my addressing of your position. I mean, I just don't even understand why that would even be a question. But since I'm the one that coined the term, I can use it however the heck I want. What's up, Arctic Timberwolf? How are you doing? Let's see who's in the house. Testament is here. Bubblegum Gun, what's up, man? Jamie Russell's here. How you doing, brother? Ray is in the house. Oh, awesome. Member Mr. Keith Kelvin is in the house. What's up, brother? How you doing? And Jungle's here. Mitchell's here. What's going on, guys? Appreciate y'all for coming in and listening to my my tangents here. Okay, and man, we got another. Who is this? Ascension Rebecca. Man, who's keep coming in and doing these robot stuff? Let's go ahead and the user. Okay, let's get back to it.
And in this case, when we look at things like transposons, when we look at breakage fusion models, what we see is random variation in an operational sense.
So PZ, I believe that you are imposing your view of things onto something and making a statement that you can't scientifically prove. It's mathematically impossible to prove that it's random. And so you're making an assertion that can't be confirmed. Now, I'll give you an example of a way that you could confirm that evolutionary events are random. And they are the very popular fruit fly experiments and radiation experiments that have been done since the early 1900s. If your assertion was correct, those experiments would have produced some consistent percentage of fruit flies or moths or bacteria that were better, had better organs. But in fact, those experiments didn't make better fruit flies. The best they ever achieved was getting the organism to activate its error correction systems, again, which were a study of the recent Nobel Prize. But those experiments were very disappointing. Now, if you are right, I believe that those experiments would have been successful, but those experiments failed to do what the experimenters wanted them to do. Instead, what they did was they discovered which parts of the genome cause birth defects when damaged, which then told the scientists which parts of the genome build certain structures.
Quick response from you, PZ, and we'll go to a break and continue this discussion.
Okay. Well, he was cutting in and out there, so I didn't quite get it all, but I got the gist of it. Here's the thing that, when we do these experiments, what we do see is improvement of the organism. For instance, I work on zebrafish, and I work on a highly inbred strain of zebrafish. And what we find is that over time, strains of organisms raised in the laboratory become progressively better at living in the laboratory, which may mean that they are less adaptable, less able to live in the wild. But it's a routine thing we see all the time. And under the understanding of better as used by evolutionary biologists, they fit the criterion. They get better and better at living in their environment over time.
So PZ, you are taking for granted that this happened randomly, and communication theory indicates there's no way that those adaptations were random. And my contention is that cells sensing hundreds of inputs from the environment make alterations to gene expression, epigenetics. Maybe there's horizontal gene transfer. There could be all kinds of things. In the case of your zebrafish, I would think that it's probably more along the lines of epigenetics and transposition types of events. And this is why the improvements are observed. It doesn't just happen with random inputs. It happens because the organism is responding to an input.
We will take a break there and allow PZ to come back in a short moment's time. You're listening to Unbelievable, somewhat technical debate today, but we like to do the technical debate sometimes, and two excellent guests to join me for it. We're asking today, is it time to upgrade to Evolution 2.0? That's the title.
It's so funny that PZ and then now Andrew or making the argument that this happens, therefore it must have happened through the mechanisms that I espouse as being correct. Like, I hold that it's random, therefore, because a change happened, it's random, and that's proof that my model is correct, even though I can't actually prove that it was random, and that I'm just going to completely argue that you don't know what you're talking about, and therefore what you're claiming must be false, because what I think is going to happen happens, even though you're saying the same thing's going to happen. It's just going to happen in a different way. Like, that's what we're talking about here, folks. This is where the circular logic of and reasoning of of evolution of Evo atheists gets so entertaining to listen to. Oh man, what I said was going to happen happened, but there could not possibly be any other way that it could happen. It's so good. I love it.
Of Perry Marshall's new book. He claims to have found a way to break the deadlock between Darwin and design, and it's all about the capability of the cell to organize itself, to reorganize itself. There's something rather special about the cell. It's not all random mutation acting on natural selection. Says Perry. Well, PZ disagrees. PZ Myers is our atheist guest on the line from the States, and we're going to be continuing this conversation in a moment's time. May the force be with you, and also with you. As the new Saturday of 2016, and of course, the ways to download the show. And we've already heard his response to some of what Perry has been saying on today's program. And as far as PZ is concerned, nothing that Perry's brought up, or the intelligent design community, or any other form of response to Darwinian evolution has actually managed to, if you like, create an adequate response at this point. Obviously, what we're hearing here from Perry, though, PZ, in that last section is simply that, as far as he can tell, they're simply what you describe as randomness, as the typical, if you like, Darwinian evolutionary model. Can just as easily be, and more easily in Perry's view, be described as this kind of very purposed kind of response to environment and stimuli and so on. And when we do try and do the experiments where we kind of influence that ourselves and try to introduce mutations and so on, it rarely, if ever, produces beneficial mutations and so on. So yeah, feel free to respond, and we'll then move things along a bit in the conversation.
So what's frustrating about talking to Perry here is that he keeps throwing out these words, and as if they're magic incantations that explain things. So for instance, when he was talking about my zebrafish and how they get better at living in a laboratory environment over years, he says transposition. And I'm sitting here wondering, what the heck is he talking about? Transposition is a very specific genetic and molecular phenomenon. You don't simply say transposition as if it solves everything, because it doesn't. Transposition is another mechanism that causes random mutations in the genome. So in a sense, he's right. Yeah, we get random variations in individual zebrafish that are then selected for by their presence in the lab environment that leads to the next generation, the survivors.
Okay, so ladies and gentlemen, we have here another example of the atheist hyper-literalist disorder and the inability for many, many atheists to grasp a broader perspective on things, right? So number one, Perry stated multiple possibilities for what could be causing the improvement, or a combination of them. And yet PZ is now dismissing it on, oh, well, this is just random. Again, circular logic. I'm claiming that this is completely random, even though my opponent is claiming that it might not actually be random. There might actually be a reason for this to be what appears to be random, actually being very specific from a computation perspective. And because I am claiming that he said this is the only thing rather than a potential combination of things, and that the one you're now discussing isn't actually random, that you, as you claim it, is random, therefore what he's saying has no balance, no basis, and must just be a misrepresentation or misinterpretation or misapplication of a concept. Therefore, we can just hand wave away the point that's being made and then circle back around to your safe space and claim that, well, anybody who disagrees with me is just wrong and doesn't know what they're talking about, or there can be no potential validity to their alternative reasoning for the same outcome, which again tends to be an extraordinarily common position taken by, well, most Evo atheists. It's kind of fascinating.
Being better able to live in a lab environment. But as far as directedness, there's absolutely no evidence for that. There have been many experiments done with transposons in flies and other organisms. They do have specific sequences they like to zoom in on, but those sequences are common throughout the genome. So you can't simply say there's some kind of directedness to it, no purpose. In fact, the whole argument rests on the fact that he is proposing this amazing mechanism in which there is purposeful modification of the cell by the cell, and he's the one with no evidence for that. We've got decades worth of evidence in biology supporting the idea of random genetic change.
PZ, none of your evidence supports random genetic change because there's no way to prove randomness in mathematics. Now, what we can do is we can say, does this fit certain patterns? And you said it follows specific, it tends to conform to specific sequences. And, transposons don't just jump to anywhere. There are certain places that they are more likely to go to than others. There is a definite pattern. It's kind of like if you read the newspaper, the letter E is going to appear 13% of the time, and the letter Z is going to appear about 0.1% of the time. And we see a similar statistical profile in genetics where you see specific gene sequences, specific percentages of the time. And if it was actually random, you would not get these, they're called ergodic patterns, which is, so for example, the letter U almost always follows the letter Q in the English language. That's an ergodic pattern. There's ergodic patterns all over biology, and they specifically and directly contradict your claims of randomness.
No,
you're groaning, PZ. Why are you groaning?
Because he's ignoring all the evidence. Okay, yeah, you've got a metaphor, and you are shackled to this metaphor of a computer code or a language or whatever. It's in.
Ladies and gentlemen, what do we have here with PZ Myers? Yet another example of it's just so hilarious to me of the desperation of Evo atheists to avoid the reality that you're dealing with real code with like linguistic properties that I think it's maybe 10. I think the most recent study I saw was like has 10 of the 13 most common factors in human languages are in place in genetics, but that's a whole nother conversation. He's like, no, the research says my position is that there is nothing here. And it's like, okay, so there are specific locales where this stuff happens, or there are not. If there are, then it's specific patterns. It's not random. Genius. Like, think about this for a second. And again, ladies and gentlemen, listen to the desperation of the ignorance of PZ Myers on these topics, and the fact that he just clings to random mutation. It's just, deterministic chemical reactions, yada, yada, yada. And anything that says otherwise can just be dismissed out of hand with some hand waving, and we can just ignore the obvious. It's so funny to me.
Invalid here. That when we do real biological experiments, we can make predictions about the results based on chance, and they work. They actually work. So for example, a really simple kind of experiment that I do with students every year is we are doing mapping experiments. We're mapping genes in the genome. And this is a process in which you encourage recombination. You do breeding experiments, and you get random recombination of pieces of chromosomes. And what that means is that if two genes are really close together, there's a low chance that there will be a recombination event between them. If two genes are far apart, there's a greater chance that there will be a recombination event between them, just because of the physical properties of the chromosome. We can do this, and what we see is it works, that every time we can do mapping of genes, we can tell which genes are closer to other genes by looking at recombination frequency. So this is a case where we're using the predictions of chance events in the genome to map out the structures there. Furthermore, when these same animals, these same organisms are taken and subjected to a molecular analysis, well, for instance, we sequence the entire DNA strand, what we find is that proportionally we're largely correct. Yeah, that chance events do a really good job of mapping out the distribution and location of genes on a chromosome.
But the breakage points are not random. You're moving genes. You're moving genes around, and the genes are staying intact, or sections of the genes are staying intact. They're not just breaking anywhere.
No, they can. Well, let's not confuse this with a uniform random distribution. It's not a uniform random distribution. There are places that are hotspots for breakage, but when you look at this, yes, you do get cases where it breaks in the middle of a gene, and you get a recombination event that bridges right at the point of a gene. You get them in the intergenic regions, but those are larger, so you're more likely to get them there. That's the whole point of the experiment, is that when genes are far apart, you get many more recombination events between them. And when they're close together.
Now, as a layman coming in here, okay, between two people who obviously disagree on, and I'm not following every aspect of this debate, but if I could try and boil it down, as I often try to, you're saying on the one hand, PZ, when you get these events going on in the cell at the genetic level, when you look at what's happening when a cell's repairing itself in some way or whatever it's doing it on the basis of kind of statistical probabilities will kind of play their part, and something will happen, but you can see that it's happening because of the the physics of the thing and the way it all plays out. Perry's contention is, on the other hand, is that no, there's something really purposive going on here, that in some way that the cell itself is exhibiting almost a desire, let's say, to repair itself, rather than it just being the random events kind of that, when all added together, do create something that ultimately helps the next generation to improve and all the rest of it. I've probably not described that brilliantly, but
no, you're actually, I think that's a good point to make, is that yes, you would expect that if there was intent, that this cell would be trying to optimize its condition, trying to select for, without selection, just doing it by itself, designing, engineering a better solution. But the thing is, when we do those kinds of experiments, what we're typically comparing is deleterious and wild type alleles. So we've got an allele that's actually deleterious to the organism, and we're looking for a recombination event with a healthy allele. And so what will happen is that by the distance separating them, they will sort out into some organisms. For instance, it will get 2 deleterious alleles, others will get a healthy one and a deleterious one, and others that will get 2 healthy alleles. One prediction is if this was a purposeful event, you ought to get more with a double healthy combination, right?
So for you, it just looks like what you would exactly expect from your point of view.
Right. What we find is that the distribution of the deleterious traits and the distribution of the healthy ones are dictated by chance, not by the well-being of the poor fly that's going to inherit them.
Okay. What's your response to that, Perry?
There's a video, it's on the Evolution 2.0 Facebook page at the moment, where the University of Reading damaged a gene related to the tail of a bacterial flagellum. And so the flagellum didn't have a tail. And they came back after the weekend, and the organism had repaired some gene and now had a tail.
Okay.
Now, we see this over and over and over again when we look at genetic repair, that the cell is constantly trying to maintain the integrity of the genome. And again, the latest Nobel Prize is specifically about the error correction. There's 3 layers of error detection and correction. The cell is militantly defending itself against random errors. And to give an analogy that listeners would understand.
So quick interjection in relation to this stuff, that, the ongoing assertion from PZ Meyer that it's a, it must be 100% random. Oh, this one has healthy, this one has 1 healthy, 1 deleterious, or 2 deleterious, what happens, goes on here. You also have to remember that you have to take into account what level of error correction or modification or insertion of a potential solution is available to work with. So the earlier point I was making about, in terms of an AI system of, you got function A, or you've accounted for situation A and B, but the actual scenario that is needing to be addressed is not exactly A or B. However, can A expand or contract or use machine learning to account for this new variable, or can A and B work together to account for this one? You have to look at that in the same context of like what's available to the cell in order to deal with the damage or the error correction, or trying to account for this new scenario that's trying to be addressed. It's like saying, well, because it doesn't necessarily have the capacity to account for every single possibility, therefore there was no attempt to account for it. Is like, to me, that's an extraordinarily naive position to take, and a very dogmatic assertion. Because in every scenario it's not solved, therefore there could be no attempt, and it's all just random. It's kind of funny, to be honest.
PZ, please tell me if I'm misquoting you, but is suggesting that if this were a newspaper article, the words and phrases could get broken up in all kinds of unspecific, statistically random places and rearranged, and sometimes they're helpful. And I'm saying they're actually obeying the rules of a grammar. And the words are moving around intact, or subsets of words, like words with 2 parts are being.
Yeah, there's an editor somewhere in the background who's making sure that you don't just end up with a scrambled article.
Yes.
In some way. I mean, I'd like to move this maybe to the bigger picture, because I'm obviously not going to get you guys to agree on these specifics about these genomes and so on. But I mean, one thing that you make the suggestion of in the book is that the junk DNA debate that's been going on for the last few years, where you believe that this is an example of the way in which your thesis is kind of being borne out in some way. Do you want to just talk to that, Perry, and we'll have PZ respond?
Yes. So, Craig Venter was asked not too long ago, what is your opinion about junk DNA? And he said, a lot of arrogant people have prematurely announced that our 90% of our DNA is junk. And he's not willing to jump to that hasty conclusion. I think that's a very hasty conclusion. Nature is not nearly that wasteful. Now, PZ says a lot of interesting things about junk DNA. He says, junk gibberish with occasional bits of translated codes that convert to proteins with regular regulatory elements. PZ, your view of the genome as this kind of junkyard, or I think it's completely wrong, and I think that time will prove that wrong. I think it's an anti-scientific position to take.
Throwing down the gauntlet there, PZ. Just explain briefly, for the sake of listeners, what junk DNA is and why you think it is a good indicator of why evolution is, in that sense, a random process at bottom.
Okay, well, yeah, so junk DNA, it's a complicated term. There's lots of things that have been called junk DNA that are not junk DNA, but roughly 90% of the human genome has no purpose along the lines of assisting us in our life. Okay, it has no functional role, no functional human role, although it may have some selfish genome roles to play.
Man, PZ 90% has no purpose, no function. Man, that's a very, very strong assertion. It's kind of interesting how, there's these papers coming out about how we need to redefine what pseudogenes are. And hey, we need to stop acting like they don't do anything. You've got piRNAs that until very, very well, like a year and a half ago, were, they don't really do anything. There's a few little minor things they do. A few of them do some stuff, but there's no reason for them. And then they find out oh man, turns out there's millions of them. And we thought they only had relevance in germline cells, but hey, turns out there's a lot more relevance to them. And same thing with miRNAs and siRNAs and all these different non-coding regions that we keep finding on a monthly basis. There's new research coming out about how they do have function and they do have relevance. And even I think here in a moment he's going to talk about lines and signs and all these different things. They were if you just go and Google it over the last couple of years, there's more and more papers coming out it does this and it does that and it does X, Y, and Z. And turns out that what we thought didn't do anything actually does do something. And it's man, the PZ Myers of the world and these just dogmatic assertions that there is nothing that does nothing, I say. It just cracks me up to no end. They claim that everybody who disagrees with that position doesn't know what the heck they're talking about, when it's do you not actually go pay attention to the research that's coming out in the medical research that's happening that says the polar opposite of your position? It's really amazing. All right, let's continue.
So I have to throw the gauntlet back because yes, I read Perry's section on junk DNA, and it was disgracefully dishonest. This is simply awful what he says here. I'll just quote it from page 273. He says, ENCODE's findings were unambiguous. At least 80% of our DNA is active and necessary. If you deleted it, our bodies would fail. Our children or grandchildren would be missing something critical that they need to survive. That's a complete lie. I will say that right up front. Not even ENCODE, and I have a lot of disagreements with ENCODE. I don't think they did a good job, but not even ENCODE would agree with that. That's simply not something that they determined at all. That the ENCODE experiments, they define function as simply binding any other protein in the cell. It's the loosest possible definition of function. They have done no experiments to determine whether those elements are active or necessary, and they definitely have not done any experiments in which they've deleted some of the junk DNA to see if it has an effect. So to make that claim, this is very characteristic of his book, is that he makes these sweeping, strange arguments that are informed more by his prejudices than they are by actually evaluating the facts appropriately.
Okay.
For another thing he says, the burden of proof that junk DNA is truly junk is on them until they understand everything and explain every nuance of the genome's operation in precise detail until they can build a cell from scratch. Their job is not done. That is also false because most of the junk DNA, we actually know what it does. That, for instance, there are transposases that are part of the junk DNA. They have no function for the cell. There are reverse transcriptases that are relics of past viral infections. There's a lot of the junk DNA we have categorized. We know exactly what it does, and it does not contribute to the well-being of the organism.
It's kind of historic, hence the name junk.
One thing that's so funny about, again, the assertions made by PZ Meyer there, and we know that it has no function. Well, then how is it then, as the imaging technology continues to improve, we keep discovering things that what we thought didn't do anything actually does something? And then the fact that we now have developed technology which, to an extent, we're being able to do observations in vivo versus being limited to in vitro, we're finding out that, oh, wait, this thing we thought didn't do anything when we were looking at it in the Petri dish, turns out it actually kind of does do something. It's let's just think about this logically for a second, folks. Let's say you have a car part a pump or something, and you've taken it out of the engine, and it's just sitting there on the table, and you're like, I just don't. And let's say you've never seen like how it actually operates inside of the car engine, right? And you're sitting there looking at like, I don't think that this part has any relevance because the way it's sitting here, I'm not seeing any movement. There's nothing passing through this hose over here. And this little turbine doesn't really do anything, or this little fan or whatever. Like, I don't see how this has any relevance to the engine or the operation of this vehicle, right? And then you find out that like it's the freaking fuel pump. Like, I mean, anybody would look at the person making that dogmatic assertion and be like, yeah, so you're an idiot who is claiming because you don't know how something works or because you haven't seen it operating while you're driving down the freaking road. In this context, driving down the road is like the in vivo, right? Versus in vitro sitting, at the shop, sitting on the bench. Okay, bro. Congratulations on your very dogmatic assertion, but I'm just going to go with the fact that now we have a little camera that we've got sitting on here as it drives down the road, and we're now being able to observe like how it actually operates inside the engine while you're driving. I'm just going to go and say I'm not going to listen to you anymore because I think you're full of BS. And the fact that you didn't know how something works, cool, bro. Awesome. Let's move on.
DNA that played a role at one point in our evolutionary history, but no longer does. And for you is yet another reason to show why this, the idea of
yes,
purpose
and we actually know what it does. If you find a sequence, there's sequences called lines, for instance, or transcriptases, and we know exactly what they are. We know what their enzyme does. It copies RNA back into DNA, which is not a function that our bodies use, but viruses do.
Well, let's allow Perry to pick up this gauntlet again in order to throw it back across the line.
PZ is a little bit of gauntlet slapping.
Yeah, absolutely. I expected no less. PZ says you've completely misrepresented this in code findings, Perry.
So PZ, has anyone deleted this junk DNA and seen what you get?
Well, yes, there have been experiments in which large stretches of DNA have been deleted from organisms like mice, and most of that has absolutely no effect.
So I would predict that if you run the experiment 10 or 20 or 50 generations, you will find that that does get used. It is necessary. It is helpful and useful. And I think it's extremely premature to say that it's junk. And if you can't build an organism from scratch, again, I go to what Craig Venter said. He engineered a synthetic genome and injected into a cell and got it to work. And if you did this on a grander scale and you let the experiments run long enough, I think you would find that there's a whole bunch of stuff in there that's not junk. And one of the reasons I believe this is true is, the human genome is only 750 megabytes. It's about the size of a CD. Considering that 750 megabytes contains most of the instructions for building human body, yet Mac OS takes about 7 CDs and Windows takes 20. So first of all, I'm really impressed that the job gets done in 750. What you're saying is the job is actually being done in 75, which is just flat out extraordinary.
Such a great point there, man. I'm folks who listen to debates and different conversations. You've heard me make very similar points in terms like that seems like a little bit kind of like you actually. I think the analogy I've sometimes used is like the Boston Dynamics robots that can like run, jump, have spatial perception, can dance now, and like synchronicity with other robots and do music and such. It's like, do you actually think that they're pulling that off in less than a gigabyte for the operating system? I don't think so. You're actually going to sit here and tell me that there's less data necessary in to like make a human or like all these other organisms run around and be able to do so? I don't buy it. I really don't buy it. And then when you factor in the reality that the data compression capabilities of DNA are just so mind-boggling that tech companies are investing billions of dollars into trying to apply it to our own data storage and computation technologies. It's like, yeah, so Evo biologist, I know you're desperate for this not to be true, but on the other side of reality, everybody's accepting the fact that this is like the capabilities of this is like out of control and just so like beyond what our current technology is capable of accomplishing, that we're trying to copy this other type of technology that you want to claim isn't extra technology and isn't extra information processing, all these different things. Like, okay. PZ, I think it may be time for you to retire because it's pretty obvious that you and your ilk are desperate to avoid the obvious and don't want to address anything that, starts to crumble your conventional paradigm dogma.
I think you can get that much good code in 75 megabytes, and if you can, it's the best code I've ever seen. And so I think it's really premature.
You don't see that this metaphor is totally self-refuting? You're trying to compare the human genome to the information in code on a CD, and you're pointing out that it's really, really tiny.
Again, another atheist with, it's just a metaphor. It's not really code.
Even if we count all the junk DNA as functional, it's still really, really tiny. Doesn't it tell you right there that maybe you're making an inappropriate comparison, that you're dead wrong on trying to shoehorn the information in a cell into your rather naive conception of digital information from an electrical engineer's standpoint?
Well, I don't think that all of the information for building a human body is in the genome. I think it does reside in other places in the cell, but it's a remarkably small instruction set that builds a remarkably sophisticated machine. Again, we're using metaphors. And
I mean, PZ's fundamental objection, though, is that you've come at this as an electrical engineer, a software engineer, and you're seeing the biological processes with that kind of set of filters. And PZ says it's not this discipline. You've got the wrong analogy here. I'm interested to hear from you, Perry, why you think this is an absolutely valid analogy for biological systems.
Well, two reasons. Craig Venter is not just a software engineer; he's a biology engineer, and he's very good at it. Mm-hmm. And he says this is premature, and he's got a lot of credibility with me. And secondly, it's because bioinformatics is such a rapidly advancing field, as is systems biology, that when somebody violates a basic mathematical principle, namely information entropy, and I know that in all of the other analogous systems, what he's saying would never work, then I question his model. And all I'm saying is what's going on here is non-random, and the non-random hypothesis is more consistent with the spirit of science than the randomness, because as soon as you say random, inquiry stops. There's no further dissecting of what's going on. There's a pattern here.
PZ, you want to come back on this?
Yeah, I would love to hear Perry question his own model, because he's not doing that. Over and over again, what you do is you tell me, well, from my perspective as an electrical engineer, this doesn't work. It can't work. And I'm telling you, yeah, but biology does work. So maybe your perspective is wrong. Maybe you're coming at this from a completely invalid angle. And yet you just come back.
Okay, so PZ Myers is saying you're coming at this from the wrong angle, and that the information communication theory principles don't apply. But as anybody who's watched my channel for any time knows, there's paper after paper after paper on how information communication theory principles do apply. You've got, as Perry just mentioned, you got bioinformatics, which is like founded upon these principles. So it's like Evo biologist, like, dude, you're claiming that Perry doesn't know what he's talking about and the principles he's leveraging aren't applicable. Well, why are you shouting at him? Why don't you go like tell everybody who's like in all the PhDs who are involved in bioinformatics that they don't know what the hell they're talking about? Why don't you go tell all of the investors and the industry researchers who are applying all these principles to their research, both in the technological as well as the medical fields? Why don't you go tell them that they don't know what the heck they're talking about? Like, you're dismissing the points that Perry's making. Like, why don't you go tell your quote unquote peers that they're just wrong, out to lunch, and don't know what the hell they're talking about? Because this is what I hear ad nauseum from folks. Oh, you're not an expert in blah, blah, blah. You don't have the piece of paper and the letters after your name. Therefore, you can't have an opinion on anything. So it's like, dude, cool. I grant that you're going to, okay, fine. You want to dismiss my points? So be it. Why don't you go tell all these guys that whose research I'm referring to and have been part of the culmination of my conclusions and the points that I'm currently making? Do you think I just made all of this up out of thin air and that there's no substantiation to the points that are being made? Because I got my open folder for you. Again, whether or not you want to agree with me from the origin and the preceding necessities perspective is irrelevant to whether or not it's something that must be accounted for. But that concept seems to go over the head of the vast majority of you atheists who are blinded by their desperate need for evolution from a random perspective to be true. Otherwise, all the cool stuff that they're seeing and studying isn't really plausible to exist without a preceding intelligent agent.
I can insist on applying these fallacious ideas about electrical engineering to biology. That it's like we're in a constant circle here where you refuse to consider the possibility that maybe you're wrong.
Do you think?
I would also,
sorry, yeah, go ahead.
I also have to point out one other thing, and that is, every time I get into an argument with a creationist, they fall back on this appeal to authority. Craig Venter is a very smart guy. He's really good at what he does, but he's not an evolutionary biologist in any sense of the word. He does not do evolution. He does brute force molecular biology. And so to argue that because Craig Venter is unfamiliar with the evolutionary arguments against his interpretation does not have any kind of, doesn't hold any water with me at all.
Well, it's his brute force molecular biology that I respect, because he has to build a functional cell, and he doesn't really concern himself with where he came from. Your junk DNA theory comes from where you think it came from or how you think it got there, and I believe you're wrong, and the proof is in the pudding. If you can build a successful cell, then you must know something about the genomics, and I think he knows.
We're going to take a quick break again, and we'll have time for starting to sum things up. And I want to ask Perry in the next section, as we start to draw to a close, about your Evolution 2.0 prize and see whether PZ might have a chance at winning this. I think the prize money is up to $3 million, believe it or not. So we'll find out about that. Also, how this all in the end ties into God, because we do like to talk about God as well on Unbelievable, not just information design and biological systems. And so, let's tackle that one a little bit as well as we start to draw the program together.
All right. Well, I think it's rather obvious at this point that Myers is not even remotely open-minded about this. And obviously, Perry could have not used the appeal to Craig Venter, but I'm assuming the logic we had on that was like, I'm not appealing to some like person who's an advocate for creationism or even ID, given the fact that he's been against both. And therefore, somebody who's heavily involved in this is agreeing with me in the context of the points that you're dismissing, that information communication theory do not need to be applied to evolutionary biology in theory. It's like, man, I don't even know how these guys. Well, it's obvious that there's so much control inside of academia that is being maintained by these guys. And I in fairness, I get it. They've spent 30, 40 years of their lives espousing these positions. And if at any point they have to admit that they're wrong, then everything they've done in life gets completely negated from not necessarily all of it, but a huge portion of it gets completely annihilated from a substantive perspective, and their own sense of self-worth is at risk. And the reality is, if you're at that age, you think there's nothing beyond this existence, especially like an Evo atheist like Myers, who's like, there is nothing beyond this world. Therefore, what I've done is all that there is. Therefore, if what I have spent my entire life being dogmatic about and insulting people over is false, and I'm actually the idiot, I don't really want to deal with that. And yeah, so I'm just going to act like nothing that they are saying has any validity, and just, nope, let's ignore it. Let's not even go down that rabbit hole. Okay, I think I might play a few more minutes and see if anybody wants to jump in for a little bit of open discussion. Keep that going for maybe 30, 40 minutes, and then call it a night. So let me put a link in the side chat. Anybody who wants to come in and have a little bit of open mic discussion. All right, anybody wants to come in? Link is now inside chat. Going to pin that up at the top for anybody who wants to come in. If it will show up in YouTube, there we go. Okay. All right, messages pinned. Play this a couple more minutes, see if people want to hop in. Otherwise, we'll call it a night.
You're listening to Unbelievable with me, Justin Briley. My special guest today in the studio is Perry Marshall, author, speaker, engineer, as we've heard. And he's written this book called Evolution 2.0, in which he claims to find a way to break the deadlock between Darwin and design. And we'll continue on with PZ as well, PZ Myers, well-known atheist biologist, on the show to challenge Perry's assertions about biology and design and so on. So come back again in a short moment's time for the final part of today's program. Hello and welcome along to the final part of today's Unbelievable program.
What's up, Alec? How you doing, man?
Doing very well. I'm just astonished that PZ Myers sticks to his religion because he gets paid very well at UCLA. It's okay. Everybody needs a job, but when you run the thing, it's kind of hard to change your point of view and then get thrown under the bus by all the other underlings that he's taught this religious study of evolution.
Yeah, it's to me, it's really getting obvious that the PZ Myers of the world, the Richard Dawkins, all these guys, I mean, they just refused to allow for any modification. And it was kind of interesting in the interview I had with Perry earlier today. We were talking about that, right? Of just how there's been for the last, a lot of these guys, it seems like they just want to ignore so many of the advancements that have happened over the last, say, like 20 years at this point.
Well, the cure for cancer.
None of that happened. None of that happened. It doesn't exist. It doesn't exist. And if you say it does, you're crazy. You're ignorant. You don't know what you're talking about.
Yeah.
You just don't understand evolutionary biology.
Well, if people would just realize that cancer problem is a glucose problem of programmed cell death, and they have shelved that for many years. And that's why the breast cancer, pink tennis shoe, NFL wearing people get paid a lot of money to wear those pink tennis shoes. And only 2% goes to research of breast cancer. 2%. Now, maybe a couple $1 million, but it's the wave of the world. It's all fallen into, hey, we're going to create a pill to make you run faster, fart more, fart less, whatever it may be. We're going to make a pill for this, a pill for that. So everybody's all pilled out. Right now, there's more women on freaking downers than ever have been, Xanax included. And, it's unreal what they've created in very little amount of time, because it kind of came in like a low tide rising. And then all of a sudden the tidal wave hit probably about 12 years ago. That's when the tidal wave really freaking just came on, and you can't even keep a job if, they'll have their token religious guy, but he's about as religious as, Robert Schuller back in the day. And, that's what they do. They have to play the game. So they get the government grants. That's free money from taxpayers of the United States that was started in the mid-60s, the Science Foundation. And everybody's got their piece of the pie in it. And I'll just go back to Lenski one more time. 300,000 generations of freaking E. coli. Guess what we got? Just guess. E. coli.
Yeah. Yeah. It's
millions of years.
Yeah, and as people have heard me talk about many times, I mean, I've made the analogies of AI and machine learning and all that kind of stuff that we're observing in cells. And it's like, to me, I don't have a problem with that. And I don't think a lot of people who believe in, some type of creation do either. Like, it's like, when you think about it from the front-loaded genome model, right? Like, yeah, you have all sorts of possible capabilities, and there's no reason to assume that you wouldn't have modification and adaptation capabilities pre-programmed. And, the level to which those can be executed and what is the end result might be a difference of opinion, right? But I don't have an issue with that existing. In fact, I think it gives more indication that there would be a hyper-intelligent preceding agent necessary in order for that kind of stuff, that capability to exist in the first place.
Right.
That lends more evidence, in my opinion, to the intelligent agent being necessary than less. Yeah. Like, that doesn't remove it at all. Like, what are you guys talking about? Do you guys not understand what you're claiming here?
Well, just as you're saying, maybe in a different way, all that we've learned has come from life itself. So, the study of the AGCT and everything like that, quaternary code, we're still stuck in binary code. Everything that we've learned has come from some sort of a earthly finding. Not talking about evolution, just talking about the fact that, what is it? The Fibonacci, design. All the flowers, all the mollusks, all the everything has the Fibonacci code to it. It's just amazing that you can break it down mathematically, and math is very recent. Calculus was only founded in the 1700s, right? You know,
Yep,
so
Newton
yeah,
developed that.
exactly right.
You're right.
Yeah,
Not a very
Principia Mathematica. Yeah,
like less than 400 years, right?
yeah. It's unbelievable that well, just in the past 400 years, as you say, look at how fast everything has, you know, just grown on top of other things, structures of buildings. They're finding, you know, even through cars, they're using a simple chicken egg as a design for less, you know, deaths during accidents. You know, because it's hard to crush an egg when it's standing up, but on its sides, it's very, you know, it's more susceptible to break, obviously. It's just weaker on the sides, but the way the eggshell is, it's very hard to break. You know, you can actually stand on one if you do it properly. And not hard boiled either. But the, you know, just the amazing nature had to have been, you know, created. That's the bottom line. There's no random, you know, I can't just throw stuff into the middle of the street and, you know, like a lot of these video games and start building my village and building a castle. And I mean, it's just, you know, video games are fun, but I think a lot of people get too much of their education from it. You know, I just look at, you know, PZ Myers, he's just trapped. There's no way he can get out of it. And he's happy because, you know, he gets to pervert the little girls that come into the classroom when he does his little talks and all that fun stuff. And, you know, I've seen it firsthand. You know, I know a lot of the jokers that are around. You know, the guy, same scenario that happened to me, the guy at Baylor, he's a intelligent design guy. What's his name? Brewster, or begins with a B. Yeah, they kicked his ass out. You know, he got some government funding and he decided to do you know, a study on something, and he got about 1/8 of the way through after they got the funding, and they kicked his ass out.
Yeah, it's a common trend. Something I've been thinking about a lot of this past 2 years is the, you know, with the removal of so many of the blue sky laws in terms of investment. One of the things I've really been thinking about is putting together a research fund and then actively go after, like, basically doing equity crowdfunding on a nationwide scale, and look at it from a, hey folks, let's think about this rationally for a second. We've created a academic bubble that researchers must go bow and scrape to the NIH and HHS, right, and, you know, basically kiss the proverbial ass of people like Fauci and, you know, that ilk to right, get funding, right? Yep. And or a combination of that along with big pharma, right? There are some private endowments that do it, but those guys usually have investments with pharma, right? So it's like this big incestuous relationship, and there's not external sources for people to be able to challenge the status quo out of the risk of never getting funding. Like, we see this all the time, right? Like, there's people who are hardcore going after folks like James Tour.
He's already been hammered. He's all private funding now. He cannot get any grants from Rice. He can't get anything. They've already told him that.
Right, but he's had 6 IPOs in the last, or 4 IPOs in the last 6 years. So getting private capital for somebody like him, no big deal. It's like, hey guys, we're like, we are the freaking bee's knees. Like, all these little ideologue dumbasses can, you know, take their bullshit and shove it, because here's what we bring to the table, right? But my point being, he is the rarity. I mean, he's a brilliant. I mean, he's a once in a century type of mind anyway, right? But the other folks that are up and coming, like, the point I'm making is, I wonder how much brilliance and how much discoveries have been prevented by the fact that there's so many folks who, because of their worldview, don't get funded. So anyway, my long-winded diatribe here is, I've been seriously contemplating for example, the equity crowdfunding rules have been expanded to where you're able to raise $75 million a year,
right,
from non-accredited investors, right? So, I mean, $75 million a year, that's a shitload of money.
That's a ton of money.
You could fund a lot of research for $75 million, right? And if you're able to do this from a long-term investment perspective for the equity holders, right? Of, hey
Right.
guys,
Well,
you might not see return on this for a long time, right?
right. Well,
However,
add that as a 501c. Add that as a 501c.
Well, you couldn't be doing equity funding as a nonprofit, but
No, I'm saying you could. There's ways to finagle that.
well, there are ways.
Goodwill.
There are ways, but I'm saying from from an investment opportunity perspective, right? So
yeah,
you have to think about it from a medical research or a bioengineering standpoint.
It would have to be Skunk Works, man. It'd have to be Skunk Works. They'll find you out.
Well, no, I'm not. You can do this publicly. Like, this doesn't have to be a.
No, I'm talking about the ones that don't want that. They want everything to be academia, university, student loan debt, the whole 9 yards. It's all a freaking game.
Well, no, I agree with you, but I'm saying this would be creating a new paradigm, right? Of
yeah.
Hey guys,
no, I get where you're going.
You
with
don't have to remain
saying,
inside this little universe. You can step outside, and you make it a very public appeal to, forward-thinking minds who are willing to challenge the status quo, right?
Yeah.
And be like, hey, academics, I know you're out there. I know that you exist inside these bubbles. I know you guys hate having to bow and scrape to 5 or 6 major players, and
right.
Hope that they will, if you challenge anything that they claim, or any of the conventional paradigms, you're guaranteed to be annihilated. Like, let's create a new paradigm. And in my opinion, the only way to pull that off is to go to the normal folks and be like, listen, guys, this is a long-term investment. You might not see a return for 20 years. However, the amount of capital you're going to risk individually is not that big, number one. And number two, because you can go from a volume perspective. And number two, it doesn't take, like, these big time returns, they can get acquired. The IP will be purchased by big pharma, right? If we're able to find solutions, they pay billions.
Oh yeah.
So it only takes one to, and let's say for easy math, let's say for $75 million a year, you're being able to fund, reasonably be able to fund, say, 50 teams, right?
Right. Oh yeah.
That's a lot of potential.
That's a huge potential.
That many minds being able to be operating on different things. Like, come on now. The technology increases, like I've looked into this before, like the capital investment, a lot of it's on the front end, right? For the equipment, all that kind of stuff. And after that, it's the mind. It's the mental capital that you need.
Right.
And there's operating expenses for the research labs and all that kind of stuff, and like the materials they need. But that is, the human capital is the major portion of it, right? So $75 million, you can pay a lot of people a good salary for $75 million a year. You know what I'm saying? Like, you can be doing well. And I mean, I know from like my experience, like, I know how many people you can pay a decent salary to for, a couple $1 million a year in revenue. It's
when I ran my business, similar to it, I just got investor money, put on concerts, hired the crew. That took about 3 months to design, and you made a cash cow at the end. Yeah.
In this kind of case, it's a long tail move, but it's interesting. Okay, I've been talking for a while. What's up, Bubblegum Gun, also known as Corporate Operator Bubble? What's up, man? How you doing?
Hey, what's happening? Did you guys hear about the Ukraine getting bombed?
Yes. I had Slavic's message up a little earlier. Yes, we all need to pray for the Ukrainians and the Russians, and who knows what all is going on in that. What's true, what's false. But obviously, hopefully that won't degenerate into anything too crazy and can be resolved without the European Union / United States oligarchy trying to use it to their advantage for freaking World War III that they want. Hopefully we won't end up with hypersonic missiles being shot back and forth. That would suck.
Because I don't think we have hypersonic missiles, but they do.
We do, but I think the Russian version is like they've put in a lot more recent research into it.
Yeah.
So like we have them, but I think the Russian version is maybe a little bit better than ours right now. But either way, at this point, like if you're doing like close quarter firing of hypersonic missiles, I mean everybody's getting blown up. That's just the way it is.
That and I'm pretty sure like by this time period, I'm pretty sure they like snuck in like nuclear like dead men triggers within cities. So I'm pretty sure like like the U.S. has like nuclear bombs planted in like China and Russia, and they too as well with us.
Yeah, at this point, there's no telling all the stuff that's going on. That's why I say I hope that the oligarchy, the globalist oligarchy, doesn't decide to use this as a escape mechanism for the madness and the. I mean, we all know that they're trying to do a economic global reset. Like this is public information. They don't hide this. So
Yeah,
you have all the central banks talking about unveiling their own digital currencies and doing economic reset and restructuring of the global economy. Like, what better way to pull that off than let's have a mini World War III, folks? Let's just do it real quick. And the fact that we have been spending you guys into oblivion and that fiat currencies around the globe are getting ready to implode. What better way to solve this historically than let's have a war, folks? And we'll justify everything, and we can just erase a bunch of our debt. Let's do that.
Do you remember that economist back in like 2011 that was like promoting an alien invasion as to like solve the economy? Like, what if there was an alien invasion?
I don't remember hearing that one, but that doesn't surprise me. I mean, there's
he was really famous. He was a Keynesian.
Well, that explains it right there.
Yeah. So
anyway, I want to say it was like 2012, 2013. Oh man, I'm forgetting the name of the organization, but it's like one of the global like economists groups. I watched it on C-SPAN. They were testifying before Congress, right? Before the Senate. And the whole point of their presentation was that Keynesian economics had been proven to not work on a global scale. Like, okay, we now have basically a century of attempted application of the principles of Keynesian economics. And basically in every scenario where they've been tried, they suck. And they didn't use that word, but it was basically the point they were making. And it doesn't work. So we formally are telling you senators that these types of principles should no longer be employed. And then what do those dumbasses do? They I'll never forget it. Like, well, thank you for your presentation, blah, blah. Then they like cut over to the debate. And it's like, well, I think that we should continue to vote in favor of this stuff. And it's like, what the freaking egg was the point of you bringing in the quote unquote experts to explain to you what you should not do? Like, we're going to take us under advisement, yada, yada, yada. We need to listen to these experts. And as soon as they get done, like,
technically,
no, let's double down. Let's do it again. And then like fast forward to where we are now. Anybody want to try and tell me that what we've been doing for the last 2 years is not Keynesian economics on steroids? Because if you claim that otherwise, you're an idiot.
Yeah.
I mean, it's like, anyway, enough of my tangent.
Technically, they listen to them. Technically.
Yeah, just to butt in real quick. We know what an expert is. X is the unknown quantity, and a spurt is a drip under pressure.
I tell you what, you know what's really pissing me off is every article I read today, or like lately, or anything here on the news. It's like experts say insert whatever the talking point is, and it's like, yeah, how much were these quote unquote experts paid to say that? And I don't know if you saw one of the fact checker groups that Google has employed lately. It turns out that there's some group of like people out in the middle of BFE in India that are not experts in the fields they're like they're fact checking in. They've literally been hired people like didn't go to college, have basically no education to be fact checkers. They're like in huts out in in the middle of nowhere in India, and they're the quote unquote fact checkers. And it's like, okay, it's just like a bunch of the folks that like Twitter uses. They found out like they've been fact checking experts on such and such. It turns out they're like recent college graduates. Like with undergraduate degrees. Like, cool. So you've got a 22-year-old who just got their bachelor's, and they're the ones who are supposedly debunking, XYZ PhD or, person with 20, 30, 40 years of experience in a field. That's the guy who's claiming they don't know what the hell they're talking about. Interesting. No brainwashing is happening here, folks. I yield.
Well, let's get back to the or topic of evolution. I think a lot of them are just playing dumb. I think a lot of them know it's false, but they have to keep it up. They clearly do it for some external reason. I mean, come on, you guys are Christians. You guys know demons are real, and it would be absurd not to think that these things are planning conspiring against us. I bet they come and listen to you. They would have to be listening and working against you, working around you.
Well, money is the love of money, actually, is the root of all evil.
Well, demons could probably use money to manipulate humankind, but there's also people like Aaron Raw who actively seek out these things let's face it, that fat lord isn't getting laid through normal means. So a lot of people do it to get laid, wealth, and power. And in exchange, I'm pretty sure they use them to, like, quote unquote, be atheists and push this atheist nonsense.
I wouldn't be surprised if Aaron Raw might get more pee than you expect from certain demographics.
Because a lot of freaks out there, bro.
Yeah, that's what I'm saying. Like, I wouldn't be surprised if he gets. I mean, let's think about this. Dillahunty has his groupies. Raw's got the groupies. I mean, I would agree with you that many of them do this stuff in order to get laid. I would definitely agree with you on that. There's no doubt about it that they're taking advantage, whether consciously or unconsciously. I'm sure they're taking advantage of that to the extent. But then, to your point about demons, right? So Aaron Raw did recently have a coming out party, to being a Satanist. So it's not like it's being hidden anymore.
Yeah, and he admitted
the garb didn't trigger that.
Yeah, he admitted he used the Ouija board before. So I'm pretty sure he got in contact with something.
Now, Greenie says that I have groupies. And Greenie, I don't know about me having groupies. If I do, I have never taken advantage of them in that sense. And I'm unaware of their existence. But if you say so. However, I actually am seeing someone right now. And no, absolutely zero relation to YouTube aspects. But and I am seriously out kicking my coverage. It is on a daily basis, I'm seriously wondering how I managed to pull off. Getting this girl interested in me. I have no idea how I pulled this off. Absolutely no idea. But I'm counting my blessings on a daily basis. I'll tell you that much.
Are you flexing your YouTube channel on her? Like, girl?
No. I mean, what is my YouTube channel? No.
I got 2K subs.
Oh yeah. Oh yeah. What's up, girl? How you doing? You see my sub count? Oh yeah. No, I tell you what, man. I know I'm repeating myself here, but I seriously have no idea how I got this chick. I mean, she is beautiful, smart, not brainwashed, just fun. Yeah. Seriously. No.
You have a sister, bro?
You know what? I know what it is.
Absolutely no idea. I told her this the other day. I was like, I really don't know how I managed to get your attention, and how I'm keeping it. I have no idea.
It's the hat and the beard, my dude. It always works. It's like the standard look now. The hat and the beard.
Maybe, but I'm telling you, this girl could go get whoever. She's a serious rarity. And there are a lot of dudes who probably would be intimidated by her because she is very smart. But there's also a lot of guys who'd be like, holy crap. Can I possibly get this chick's attention? So I don't know. I'm doing my best to not mess this one up. I'll tell you that much. All right, anybody wants to join? We keep doing open mic for maybe like 15, 20 minutes. Well, anyone wants to hop in? Link is in the side chat.
I did get Jackson Rowe to one thing he would denounce evolution theory over.
Is it the rabbits in the Cambrian?
No, death. If he was to be put to death, they said, "Hey, are you going to believe in evolution? We're going to put you to death." He said, "Yeah, I give it up." I said, "No, I'll go to death over Christ. That's my Lord and Savior. I don't fear death." It's and I wonder how many atheists would evolutionists, I guess you could say.
I'm surprised Jackson isn't here today. So it was like on every stream.
Oh, he's been dating lately.
Oh yeah, he was with that chick.
Maybe he found a lucky one.
Nah.
Nah. No, it's
Doubt it.
really interesting when you put two, you know, in a biblical sense. You know, I have no fear of death. I know where I'm going. You know, at least I think I know where I'm going because, you know, I believe in Jesus Christ, Lord and Savior, resurrection. I am a sinner. You know, I'm just a wretched person, but saved by the grace of God. And
You ever had
know,
a paranormal experience, Alec?
no, but you know, I think I told. I'm not sure, John, if I mentioned that about my mom's um, death experience. Yeah, she had one of those near death experiences, but she actually flatlined, died, brain dead, 45 minutes, wheeling her down to the morgue elevator, and she popped up, and she can recall everything. It's amazing.
Did you go somewhere? Did you go to heaven and back?
Oh, she was basically, you know, she thought she was still in her body, is the way that, you know, she perceived it, but she could see everything in, you know, from the you know, the operating room. She was not in the body.
Oh, out of body.
When they were wheeling her down the, you know, her soul, if you want to say that, her spirit was not inside her body. It was above her body. So it was like
Out of body experience.
Oh, 100%. But she was dead. She was clinically dead. My dad, who was a physician, pulled all the stops, brought up the one of his neurosurgeons, and wanted to make sure, you know, she was actually dead, because it all started from a tubal ligation with a tubular pregnancy, and she bled out. 7 pints of blood gone, and they couldn't stop the hemorrhaging. And so she, you know, they tried to resuscitate several times. My dad, technically being a doctor and the husband, was not allowed in there, but he couldn't stop him. You know, he got in there, and I was out in the waiting room. And when I heard that she had passed away, you know, I couldn't go in there, you know, until she was gone. But you know, I witnessed exactly, you know, everything after the point of her being neurologically dead. So I was, what was I, 14 at the time, and so it was like 13, and so I remember a lot of it. And then I remember seeing the guys wheeling her off down the hall, because they have a separate elevator for the morgue. And you know, I used to go on rounds with my dad all the time, so I knew the deal. And I was just like, I just couldn't believe it. I was just in shock. And then, yeah, right before the elevator door opened, she popped up, and she could remember everything. I mean, what tie my dad was wearing, because my dad was actually at the hospital, and my older brother had to call the ambulance to pick her up. And so my dad was at the hospital, and they took her there. So she never saw what he was wearing. And then, you know, so, you know, she name tags, you know, exactly what was in the room, exactly what, you know, people in the hallway. It was crazy. So, yeah, near death experiences, you know, I believe that they're real. I've never had one. I should be dead 20 times over. I've escaped some really wicked accidents, falls, things like that, where, you know, I shouldn't be alive. But, you know, the interesting thing, I just don't fear it. Just don't fear death at all. And it'll come coming one day, one way or the other. But, you know, what's his name? Gosh, just went blank on his name. He's the evangelist that's been doing the near-death experience things by Habermas. Habermas?
Gary Habermas.
Yeah. He's doing the you know, the resurrection, and it's just, you know, basically there's no refuting the resurrection of Jesus Christ. You just can't refute it anymore. Science is befuddled by it, but it happened. There's just too much historical evidence. Romans were very particular, and that's why he was sent from, because the Pharisees and the Sanhedrin weren't allowed to put anybody to death, so they had to let the Romans do it. But they kept great historical records, and there's just too much evidence of that. And I'm just like, I used to be an evolutionist, and I think pretty much everybody used to be. I mean, I was
about the bullshit too.
Ninth grade. I was like, we had pre-biology class, ninth grade, freshman, high school.
Yeah, when I was taught that, I always felt there was something wrong. I just blindly accepted it.
But the evidence was so like, okay, we're seeing all this. We got all these textbooks and all that. And, my dad being a doctor goes, oh, it's all BS, And, I didn't realize until my sophomore year. And, it was just like, nah, this isn't real. And so, when I got into college and stuff like that, it just became more apparent to me that there's no way on this earth that a one-celled organism crawled out by itself when you figure out that a cell doesn't last that long. Even, the Lenski test deal, E. coli don't last that long. It's not it's not possible for that cell to have divided that quickly, knowing full function without already inputted with the information.
Well, in line with that point, it's like, they want to claim, oh, you're just talking about cells now. It's like, yeah, dude, we're talking about cells now that are way more advanced and have all these protection mechanisms and defense mechanisms and error correction mechanisms. They have all these things. And right now, the point you were making about the time factor, the survivability, et cetera, the ones now can't pull it off, genius. Like, why would you think that something that doesn't have all these defense mechanisms and all the things I listed off, that doesn't have them then, in per your own position, a less hospitable environment has a greater probability of survival? Like in a more hostile ecosystem? Like what? Think about that for 1 second, dude. Like, come on, let's extrapolate this out logically for a second. I don't have a shield or a mechanism like a heat shield. So are you saying that if I had one now, I have a greater chance of survival of like being next to lava, right? If I have a heat shield versus I don't have one, which one do I have a greater probability of survival in? Like, this is what we're talking about here. Like, hey, I have a heat shield and a radio. What are my chances of survival if I'm trapped with lava that's rising? Versus I don't have a heat shield and I don't have a radio. Which one gives me a greater chance? Which scenario I have to have a greater probability of survival? Like, you do not have to be a genius to figure that one out.
No.
But the Evos are like, well, they might have randomly had a heat shield fall on them and just like morph out of some rock next to them, and then all the pieces they needed, there was silicone next to them that got hot, and then it turned into a radio. Like, what?
Yeah, the transmission just popped out of a bull's butt. Yeah.
Exactly. Like, come on, folks. Like this, I don't know. The plausibility of that stuff is so far out there.
The complexity of the cell, without the DNA, you don't have a cell wall. Without the cell wall, DNA will not survive.
I love how they reply. I love how they reply is like, it's not biological, so you can't use cars as a metaphor. Like, then you just ask them. It's like, where does life come from? Non-life, right? It's like,
yeah, you were rained on a rock for millions of years, and something sprouted out, and you came from algae or a sponge or whatever they want to make up next.
Yeah, but
and Perry's made the point. SFT makes the point. I make the point. So many folks make the point of like, okay, I'm not limiting biological systems to a car. I'm saying that if something like a car it's not plausible for it to create itself or the new model. And then we're talking about something that is exponentially more advanced technologically than the car. If it's not plausible for the car, then it should definitely not be plausible for something that's way more complicated than the car.
Yeah, they can't put that together. It's like they just like intentionally. I think their brain is intentionally just like.
I agree. It's like because in the context of the cell, right? It's like I agree with you. You know what? You are 100% right. The car is not an appropriate analogy. You're right. You're totally right. Actually, let me rephrase. All of the factories that are necessary to create all of the parts that are used to make the freaking car. That's what we're talking about. Then let's do that comparison.
Right.
So you're right. You have Evos. You're so right. Cars are a horrible analogy. 100% agree with you. Let's go up about 17 levels. Okay. Oh wait, and we also need to account for all of the mining technology.
The tooling
to extract all of the raw elements that are needed to go to be, and then we have to have all the capacity to, purify, put all those things together, and then ship all of that stuff to the factories and then put the car together. How about that? Because
vulcanized rubber, plastics.
The car is more like a protein complex.
LPP. It's just chemicals, bro.
Well, I stand corrected, man. It's just a bunch of random stuff. I apologize.
Are you going to do the Diet Coke assembly? Are you going to do that one? The fizz of the Coke.
Self-replicating Pepsi? Heck yes.
But it is not a code. It's a chemical. It's deoxyribonucleic acid. It's an acid. I don't understand why you think it's a code. DNA is no more of a code than Diet Coke and regular Coke.
Classic.
I love that.
That clip is never going to get old. It's just impossible. I mean, that is just it's so good. And this clip also I love for just putting the stupidity of Evo atheism into context too.
So you're telling me there's a chance? Yeah!
Yeah. John, you've seen a lot of things in your life. We talked about swimming, we talked about a whole bunch of other stuff, right? It's just, how can you train yourself to go a full lap underwater? How can you train yourself to, go faster in water? It's a substance with high resistance, especially to the human body. How does that happen where your muscles build up, know exactly the memory to bring it back? Because I know you're not a weakling, because you've got that muscle memory. If you went in and pumped iron, it would come back to you. That's just how that works, right? And it's just like there's no way, but yet there are people like an Andrew Cumming or somebody like that that's going to, come into the the thing and say, well, billions of years ago, there was a big bang, and then, all of a sudden, the Earth was formed out of a hot molten rock that just perfectly was 93 million miles away from the nearest star, that creates seasons and allows all this stuff just cannot happen. It's like you on a golf course hitting holes in one all at the same time for 18 holes. I'm not talking about miniature golf either.
Oh yeah, for sure. Well, case in point, right? Like I talk about this all the time, but when you think about the Olympics and you have all of these people of all these different skills coming together to perform, right? How that on its face doesn't debunk the whole like we suck, we're horrible, where there's no design here, there's nothing special about humans, we actually suck. Humans suck. It's like really? Because I'm pretty sure something like the Olympics just exemplifies the reality that we are amazing creatures. Like our bodies have such amazing capacity, and you're like, well, there's eagles that their eyeballs are better than ours. And it's like, okay, so they have a hyper specific function that enables them to like see really far. Cool.
Which ancient country was the one that invented the Olympics? Was it Greek or Rome?
It was the Greeks. But real quick, case in point, like this this guy right here is a Kilgo, I think his name is. But yeah, Jordan, he's like a white guy that can jump. It's pretty amazing. But he's like a ridiculous dunker. Okay, and look at these. Watch what this guy does and comes up with a new dunk. And tell me that you think it's remotely plausible that a bunch of chimpanzees would be able to come up with this and then execute it. Let's just come on, think about this for real. I mean, that's freaking awesome.
Swag.
That's nuts that dude was able to pull that off, right? I mean, come on, folks.
Was that dude perfect?
Huh?
Was that dude perfect?
I don't know if he's perfect now, but that's a pretty amazing.
I know, Dude Perfect, the YouTube channel.
Oh, that was what I was playing. No, that's it's Jordan Killian, his name. He's like one of the best dunkers. One of the best dunkers alive. Stuff he does. He's got something ridiculous, like a 40-something inch vertical, and completely disproves the whole white man can't jump.
Yeah, he's like a freak of nature, like Karch Karai was. Yeah, I used to watch him on the beach. He could jump just as high off the sand as he could on the freaking hard floor. That's nuts. You know, yeah, some of these guys, just phenomenal athletes, but if you put your mind to it, that's an amazing thing, you know?
Yeah, also helps if you had the good genetics. Well, not broken genetics. Let's put that correct.
But I'd say I was watching some stuff earlier. These guys, these dunkers, that some of these dudes who are 5'9", can get they can literally whack their head against the rim, and it's like.
Well, you remember Spud Webb, right?
Oh yeah, good old 5'7" Spud Webb.
Yeah,
was he 1986?
Yeah,
yes.
That guy. Oh wow, that was insane. And Muggsy Bogues.
Well,
Same difference.
He was quick. He didn't have the same leaping ability, but he was
he didn't.
Quick as a whip.
But he could get up there.
He was 5'3" and was able to. He had a 12, 13-year NBA career. I mean, survived running around through the trees, and I mean, it's amazing. Yeah, it was actually legit. It wasn't just a bench player. He was a starter. It's truly amazing.
No, and he wasn't just a plant either. Just letting him play. You know, it was he had to earn his stripes. You know.
Yep. But yeah, those. The point being, obviously, we're using these guys as examples, but the amazing capabilities of the human body are, to me, just so indicative of the fact that we are fearfully and wonderfully made, number one. And number two, the premise that we have the pre-existing capacity to perfect all of these different skills is just, it's too big a leap for me. And right now I'm talking about sports, right? But then on the flip side, you have to look at music, right? The pianists and guitar players and violinists and cellists and people who play the flute and all these different instruments, like the exquisite amount of control that is required and the ability to understand information and to read music and to create music.
I'm very jealous of musicians. How they able to express feelings into finger motions, and that produces a wonderful sound. I'm like, how are you able to do that?
Right. Well, I agree with you completely. But on the going the one route below that, you have to think about, the Beethovens and the Mozarts and all those guys and men and women who created these just astonishing pieces of music, right? And what are they? They've done it in their heads, and they've been able to visualize and to hear in their own mind what they are creating, and they're putting down on paper, right? And
Beethoven was deaf,
right? And he wasn't always deaf, but he became deaf,
right?
And actually, he wrote the majority of his well-known pieces were written after he became completely deaf.
Correct.
Well, here's an interesting, because they feel the music. They use their feelings to produce the finger motions.
Yeah, the vibration.
So it becomes expressive. So they're not thinking about it; they're feeling it.
Right. And you're 100% right. And to me, when you think about the capabilities of the human mind, right, and what skills are necessary to, and from in relation to your consciousness, to be able to do these things, right? And the foresight and the ability to envision things that do not yet exist. For me, when you contemplate the aspect of what does it mean to be made in the likeness of God, right? If God is the ultimate creator, and we're basically like micro creators, right? We're able to still create. We can't create things on the macro level like the creator God would have to be, right? But we are able to create things that do not yet exist. And what does that necessitate? It necessitates consciousness, the mind, the ability to have foresight, forethought, et cetera, and that is what truly defines us between the other organisms, right? Yes, they can do computation, there's cognition, there's different things going on, but not in the same context in which humans operate. And the more our understanding of our capabilities continues to grow, to me, the less plausible the removal of the preceding intelligent agent giving us that power it becomes. And I could be wrong, but I don't know. The hard problem of consciousness to me just gets greater and greater by the day.
Yeah, I just think of my son. I'm not musically inclined. My wife's side was. My son, I was going to buy him a brand new guitar. I hooked it up with the guitar center guy and all that. So we're talking about it. I was going to surprise him with it. And all of a sudden, you hear this thing going off and you're like, what the hell's happening? And people are like just looking down the aisle. This is back when Guitar Center was like flooded. We're talking, let's see, 2004, 2005, somewhere in that range. And we're looking, and it's my son with the amp turned all the way up to 10, and one-handed doing Thunderstruck by AC/DC.
Awesome.
One-handed. One
Nice.
freaking handed. I was like, what? But, it's just one of those talents that he's finally cutting a real album. And the studio he's at is top of the rank in Nashville. So you should see all the freaking monitors inside the studio, dude. They just take every single piece of music and they tune it down, through the monitors. Everything's all synced up, all the instruments, everything's all done like that. So I'm really interested to see how this album turns out. He's 2 months into it right now.
Yeah, so, I live in Nashville, and one of the things that always kind of, I tell folks that I've been spoiled, right, over the last 12 years living in Nashville, just the incredible musicians, the talent, the skills. And it's like you go down on Broadway and the performances that are happening in the bars down there every day they start at 11 o'clock in the morning and go till 2 o'clock, 3 o'clock in the morning, right? And all these bands are coming in, and just the sheer talent, both singing from a lyrical perspective and a vocal perspective, as well as the musicians. It's off the chain, man. It's ridiculous, and
totally amazing. If nobody's been there and they get behind the scenes, it's an awesome place.
It's nuts, and that's why I have such a hard time with like pop music, like music on the radio, like listening to music on the radio and stuff, because it's like, yeah, okay, it's decent, but then lots of these folks that like quote unquote make it suck compared to this talent that getting paid $50 a night to go out there and play, right? And all the plethora of bars on Broadway. And it's like dudes that are better singers, better singers, better musicians overall than these clowns so many of these clowns have become like famous. And it's like, what is happening right now? Give me a very jaded feeling about modern music.
They got really good producers. The artists themselves aren't that good. I think music kind of peaked in the 80s.
Yeah, I would agree with you on that. I think 80s was where it was at. For rap, obviously it was mid to late 90s.
Well, just like we were
Nice.
talking about, the academies and things like that. The studios are pretty much set up like that. They can, take a Taylor Swift and turn her into what she was. I don't want to go into that story, but it's interesting the amount of talent that's out there that's not being used because they want to focus on different models at this moment, and it may pass you by if you're not able to adapt to that. So it's very it's very tight knit. So they'll let you in, or they won't keep you. If you don't play the game, and it's very tough. It's a tough industry. It's not as easy as people think. But I go back to the old Brady Bunch, Johnny Bravo episode where Greg Brady fit the suit. That was the only reason he was asked to lead the band, Johnny Bravo.
Do the market with me.
All right, so I told myself I was cutting it off at 2 hours. So we're exactly at 2 hours. I refuse to go into the middle of the night like I usually do. Gotta get some sleep. So I want to say big thanks to everybody who's been hanging around in the side chat. Thanks to Alec and Bubble for coming in for some conversation, a little open mic action. You guys got any last words before we call it night?
Later, gamers. I'm out, and stay frosty.
I was just going to say, God bless you guys, and carry on, and through the grace of the Lord Jesus Christ, we're still here.
Absolutely, amen to that. Well, folks, thanks so much again for hanging around, for all the members and tossing money in my way. I appreciate you guys very much. Super chats, and for everybody who comes and makes the side chat interesting, lively, and engages in awesome conversation and comments. I really appreciate you guys. Makes this stuff fun for me and worthwhile to keep doing and to have some fun and share knowledge, and gives me an excuse to go try and track down people like Perry Marshall and have great conversations I would love to have with them anyway. But it's even more fun when we're able to share it with folks and allow other people to gain knowledge we wouldn't have otherwise, insights and perspectives as we contemplate things about our very existence that are some of the most fundamental things. Hey, like, I don't know why people don't want to talk about it, want to ignore it, or act like it's not things that have to be addressed. Like, hey, let's just accept whatever we're told. Like, really? Why? That's boring. Why would you want to operate your life where you just never question the status quo, nor consider that there may be other answers, other alternatives than the ones that you're being told? And given the fact that historically speaking, the quote unquote consensus that the Evo atheists are so obsessed with, so often it turns out to be wrong and being what's propagated by those in power in order to help them maintain their power. I wonder if we're observing anything like that, both in academia as well as on a political scale in the world. Why would anybody say that? Nothing weird is happening, folks. Everything is totally normal. But enough of my diatribe. Everybody go get some sleep. I hope you have a great night. And as I always say at the end of these things, make sure the end results and end conclusions that you reach are logical, plausible, and probable. Have a good one, y'all.
Amen.